Okay, in our previous video, we looked at function operations with polynomials, and in this video, we're going to be looking at function operations with radicals. So you can see up here at the top, I have f of x and g of x, and they're both radicals. And what we're going to be doing is looking at their sum, difference, product, and quotient. So with this first problem, f plus g of x, I'm adding the square root of x plus 4 and the square root of 3x plus 1. And there's nothing I can do to simplify that, so that's my answer. I have a similar thing with subtraction. There's nothing I can really do to simplify that. Now with multiplication, I'm going to be multiplying the square root of x plus 4 times the square root of 3x plus 1. And this is kind of like what you learned in intermediate algebra, where we had the square root of 3 times the square root of 7 is the square root of 21. You just multiply what's under those radical signs. And I have the square root of x plus 4 times 3x plus 1. Now I could go ahead and multiply that out, but my math lab will accept this for an answer, so we're going to leave our answer like that. With the division problem, I have the f of x, which is the square root of x plus 4, divided by the g of x, which is the square root of 3x plus 1. Now this is where my math labs have sort of changed over the years. They used to have you to rationalize the denominator, but now they accept their answer written as one radical, so the square root of x plus 4 over 3x plus 1. In our last video, when we looked at the addition of polynomials and subtraction, multiplication, and division as well, we looked at finding the domains. And in this lesson, we're not looking at finding the domains of these functions. We are going to be looking at finding the domains of the composition, and that's what's next. Okay, here I'm wanting to find f of g of x. That means I'm wanting to take my g function and put it into my f function. So I'm going to have the square root of 5 times 5x plus 2 in parentheses and then plus 40. I'm going to go ahead and distribute and simplify what's under that square root. Now at first glance, it looks like this is all I can do to simplify the square root, but if you look a little bit closer, you'll notice that 25 is a perfect square, and it's also a factor of 50. So what I'm going to do is to factor out a 25. Now I have the square root of 25 times the square root of x plus 2, and the square root of 25 is 5. Now we're going to be looking at finding the domain of this new composite function. Okay, our first step is to find any restrictions on my starting or my inner function. In that case, this is the function g. So what restrictions do I have on this function up here? Well, it's just a simple polynomial, so I don't have any restrictions. I can put any number in for x, and I'm going to get out a real number. Now I'm going to find restrictions on my new or composite function. And this is where it can kind of get a little tricky sometimes. It's always a good idea to go back to this first step that we did right here when we first substituted the g of x in the f of x. Are there any restrictions on this function right here? Well, yes, I have to have 5 times 5x plus 2 plus 40 greater than or equal to 0. Now, before I finish this out, I want to stop and say that the reason why it's a good idea to always go back to this first step is because sometimes once you simplify along the way down here, you actually could end up with a different answer if you just looked at this bottom function of x plus 2. Now, it's not the case with this particular problem. There are some problems like that you may come across in your other math classes. Now, when I solve this inequality, I get x to be greater than or equal to negative 2. So that means my domain is from negative 2 to infinity. For my next problem, I'm going to be looking at the same two functions that I had in my previous example. But now I'm going to be finding g of f of x. So that means I'm taking the f function and I'm putting it into the g function. So I'm going to have 5 times that square root plus 2. And there's nothing that I can do to simplify that. So now we're going to be looking at the domain. Okay, any restrictions on my starting function? Well, my starting function was my f function. And yes, I have restrictions on that. What's under that radical sign has to be greater than or equal to 0. So that means x has to be greater than or equal to negative 8. Now, are there any restrictions on my new function? Well, if I look at this, I can see that I still have the same thing. What is under that radical sign still has to be greater than or equal to 0. So instead of doing that again, I'm just going to write that it is the same as above. So those are my restrictions. X is greater than or equal to negative 8. So that means my domain is from negative 8 to infinity.